Hey, have you guys heard about the new Parker Sporlan S3C case controller? Contractors, how about a case controller with a one-day setup, access to more data, and efficient system operation for the end user? The S3C series of case controllers provides contractors and store owners automated configuration and network integration. You can maintain precise food temperatures without supervisory control. Easily monitors to prevent product loss, and Bluetooth provides a local connection with the TechCheck mobile app. The series includes case controller display module, a valve supporting open protocol, communication via BACnet and Modbus. Sporlan's mobile app, the TechCheck, allows communication with the S3C case controller to enable proof of work, diagnostic, and data sharing. The S3C communicates with building automation systems and works with Sporlan's SPW series of pulse width modulation valves, also the SSR series of electronic expansion valves. Visit Sporlan.com for more information. Good afternoon, guys, and welcome to Advanced Refrigeration. You're here with your hosts, Brett Wetzel and Kevin Compass. How's your week going,
Brett?
Oh,
Oh, well, I'm back in misery. The wonderful state of Missouri, which is my personal hell.
Misery?
Yeah. This is not a fan of this state. So I'm out here doing a gas changeover. So this is changeover week. So I'm working days while everybody else nights. So I'm going in and during the day to relieve the guys doing the gas changeover at night, and then doing all my startup stuff, making sure, and then prepping up the next rack for the next day.
Sweet. I'm spending every single day smelling like hot garbage, straight up hot garbage. So apparently in Houston, there's a particular chain where they decided to put their outside rack houses next to every single dumpster that they have. And if anyone's ever been down to Houston, it's comparable to Florida weather, where it's 100 and some odd degrees and humid, and I just smell like a wet trash bag. So it's just amazing. It's awesome. Trying to do as many compressor failures and oil failures. In the past 2 days, I think I've found 2 bad separators. So, yay. Tomorrow I find out how much oil that we're going to take out of the system, so that ought to be fun.
No, maybe it'll top the 101 gallons.
No, I mean the sight glass was kind of yellow. Typically when you're looking through the sight glass, you see the copper color, right? The refrigerant was a tinge of yellow, but it wasn't like lime green, 101 gallons of oil. But I don't know. I'm going there with 4 buckets just in case, but we could always use more. Who knows? It's a loop system, so it ought to be fun.
So tonight, guys, I wanted to go over troubleshooting compressor overheat issues, and go over demingling and liquid injection and vapor injection. So we're going to get this started, and Brett, you want to take it from the top?
Yeah, if the compressor overheats, we hit it with a hammer really hard, and that should fix it. No? We're not doing that?
No.
Okay.
No.
All right. Let's go over liquid injection. Basically, mechanical and electrical mechanical. Basically, we try to maintain a good discharge temp. We don't want to really try to overheat the discharge line any hotter than 225, if at all possible. We accomplish this by a couple things. One, keeping our head pressure down, like we talked about before. We also try to make sure our suction gas is cool. It's no secret I like about 30 to 35 degrees of superheat coming back to the rack. Kevin likes living on the wild side and keeping it right at 25. Obviously, the cooler the suction gas coming back, the better, right? The happier the compressors are. We just want to make sure we don't past that threshold of 20 degrees of superheat or lower, and threaten damaging the compressor. That being said, the first type of liquid injection I'm going to go over is basically the Y1037 valve. This is a Sporlan specialty valve. It's noted so because it starts with the letter Y. It's basically a liquid injection. The model number usually starts off as F as in Frank, V as in Victor. Now, those two first letters represent F is the body style of the valve, so it actually looks exactly like a F expansion valve. V represents R22 because they use it for high compression ratio refrigerants, R22 being one and a R22 replacement. The next you'll have a dash and then a number. This number represents the tonnage. We talked about compound compressors before, and those typically always take a 1 ton valve. So that'll be that for that. Then you'll have a dash, and then you'll have a temperature, either 190 or 230 seems to be the standard. That expansion valve type bulb gets strapped to the discharge line. Don't be an asshat like me and not read the directions, and make sure that you actually wrap that bulb that goes 6 inches off of the discharge line. If you do not wrap it, it will not feed, especially if you're using head cooling fans. I was wondering when I installed a whole bunch why they weren't feeding. And lo and behold, after trying to replace the valve once or twice, finally found out that, yes, you forgot to wrap the damn thing. And as soon as I did, it started feeding. That head cooling fan will remove a crap ton of heat off of the head and off the discharge line, faking out that bulb that's on there. Those valves are sized per the engineers, whoever designed the rack, or they have to be designed in the field, whoever is installing them. A couple of years ago and still now, there's a certain customer out there where they're taking out all the Copeland scrolls and replacing them with Bitzers. There's a new control that the Bitzers are using, but before then we were using the Y1037s. Basically, you have to size them off of the saturated suction that you're running. Then you also have to size it off of the suction line temperature coming back to the compressor, and basically that and the horsepower of the compressor. And basically with those three items, it'll basically give you a flow chart, which I'll post in the Advanced Refrigeration Podcast group, basically telling you what size valve that you're going to need. Obviously, the warmer the suction gas, bigger the valve you're going to need. Lower the SST, bigger the valve you're going to need. So just be mindful of that. Especially if you're running in, there's some box stores that'll have, a medium temp and a low temp header, and they'll have these liquid injection valves on there. And basically they'll be running all medium temp on the low temp header because they usually use them as dual temp, and run maybe 3 out of the 15 cases in low temp. Now what that's going to do is increase your suction line temperature and then potentially have the compressor overheat, because it wasn't intended to have that high of a suction line temperature coming back, where a lot of times you'll have to change out the whole entire body in order to get that valve to feed properly with the with the return temperature that you're getting. So be mindful of that. We had a store that had that same situation, and I ended up just floating the suction up a couple pounds. And that helped lower the discharge line temperature at least 20 degrees. And when we did that, it wasn't failing anymore. Typically with these valves, you want some sort of stop. Preferably it'll be tied into a liquid header. You want to make sure the liquid header does have a solenoid per each compressor. We don't want it accidentally feeding liquid in the off cycle, especially if the compressor doesn't have a crankcase heater. So we want to make sure, we have some way to basically turn it on and off when the compressor comes on. You could use a current sensing relay, or you could use something as simple as an auxiliary set of contacts. Preferably, I like a CSR, current sensing relay, because the compressor basically, the contactor pulled in doesn't necessarily mean the compressor's running. And if the compressor's not running, I really don't want to jam a whole bunch of liquid in there. Anything you want to add?
Yeah, so a couple things. So with those Sporlan Y1037 valves, you could actually change the orifice in those if you need to, instead of replacing the whole valve. You could take the valve apart, and I think it's like a 5/16 or 3/8 nut driver. You could actually take the orifice out and change it out. Same thing with like the power head, just like a TXV power head, except it's just temperature responsive. So you could actually rebuild those valves in the field, the brass body isn't going to fail. It's a very low chance that the brass is going to go bad. So you could actually rebuild that without getting a torch out, just your hand tools, and take it apart and rebuild it. Like Brett was saying, Bitzer used to use like a CIC module is what it was called. So they had the Y1037 valves. Then they went to a CIC module, which is their version of demand cooling, which is no longer made, by the way. And now they have this new module. I just put like 19 of them in. Not a fan of them because they gave you no way to mount them but panel mounted. And to be honest, the thing's kind of a pain in the ass, and it's a pulse valve. So they're actually taking a pulse expansion valve, and that's how they're doing their demand cooling. They're going off of head temperature. And to be honest, I think their head temperature is a little too high. Like they're starting to inject around like almost like 275 to 285, which is really high to me. So you're getting to the point where we're getting to 300 degrees, in the heads. So you figure like most of the discharge line temps are like 225 to 235, which is pretty high. That's right at that cusp where you don't want it. It's where you're going to start cooking that oil, and that's where you start getting this burnt up oil and problems and plug strainers. Demand cooling and compressor overheating is the number one killer of compressors. Is overheating. It leads to oil breakdown, leads to cylinder wall failure, leads to compressor wear out, leads to all kinds of problems. Leads to plug strainers. So if you keep those compressors cool and keep everything happy, that's where you're going to have the best success. Now, the way I look at this, when I start looking at overheat problems, first thing I'm looking at is, what is my suction saturation running? What is it supposed to be running? Did somebody lower it a bunch? Because like Brett says, you lower that suction saturation, you're increasing your compression ratio. When you increase the compression ratio, you increase discharge temps. So same thing with head pressure. Is the head pressure elevated to the point where somebody raised the head pressure to try to hide an issue, and now we have high compression ratios? So that's one thing to look at. And the other thing, I'm checking my compressor discharge temps. You go through and check all your pumps. If you have one pump that's extremely high, that compressor may have some wear in it, some blow by, and it's causing its discharge temps to elevate, and then that compressor may be causing more issues throughout the whole rack as it elevates discharge temps. So, and then I'm looking at suction line temperatures, see what my suction line temps are going to be. The lower you keep that superheat, the lower your discharge temp's going to be. So that's one thing. Brett likes to run like 30, 35. I'm like a 25, bare minimum. I want that rack to be cold. That way, we're not overheating compressors. So that's one thing you look at. Make sure you're not spiking in the middle of the night after a defrost. I just had this problem at a store I was working at. Randomly, a bunch of compressors would trip on demand cooling, and nobody could figure out why. Well, they did a conversion from sorts to CDS valves, and what happened was post defrost, there was no longer that kind of slow pull down from a sort valve. So right after post defrac in this particular two compressors where the circuit was right above, we're getting slammed with like 180, 190 degree hot gas. So even after the drip time, it was still that warm coming back, and the suction line temp was spiking to like 90 degrees, and it was causing the compressors to trip off on a high discharge temp. So what we ended up doing was putting a pull down percentage, so that way we could kind of drain out the circuit, so that way it wouldn't hit that compressor with so much hot gas and cause that issue.
So any compressor just, has a max temperature of 65 degrees. Not saying that, yeah, we can run a low temp, running minus 25, with a 65 degree return. Just stating that, most compressors require, no more than 65 degrees. That number is typically on some of these charts, to show you that, hey, if let's just say we're running, 20, 25 degrees of superheat, and then basically, it says that we need a half-ton valve. If you're running all the way up to 65 degree return line temperature, I need to put a ton and a half in there, you know what I mean, to compensate for that excessive amount of heat. You don't want to oversize these valves. Otherwise, you could basically, flood out something. Another way that we typically do some kind of liquid injection is with the demand cooling modules made by Copeland. Basically, these things have a thermistor in the top of the head. The thermistor measures the head temperature, and like Kevin stated before, these ones also start feeding at about 292 degree head temperature, which if you basically minus 75 degrees, that'll give you your discharge line temp, which I believe is like 207. Gets all the way up. No, I'm sorry, 217. And then if it gets down to 282, it stops feeding. And at 310, that's when the alarm set of contacts is basically energized, saying, hey, you're killing this freaking compressor. It's going to die. The only real way to check these is basically pull the temperature sensor out. They do have a chart, but unfortunately, it's not like you can stick it in ice water and actually check the temperature there. It says that that at 77 degrees, it should be 90,000 ohms. Now, like I said, there is a chart that basically breaks down at what resistance, what temperature that'll be. But for all intents and purposes, I'm just going to run through, the temperature and when it actually feeds and when it stops feeding. So at 292, the demand cooling solenoid is on, and that'll be measuring about 2100 ohms. When it hits 282, demand cooling solenoid is off, and that's 2400 ohms. When it goes to 310 or above, it's about 1700 ohms, and it will de-energize the L to M within 120 seconds. And at room temperature, demand cooling solenoid obviously will be off, but it's 90,000 ohms. Because that's 77 degrees, it's nowhere near. To make sure this thing is feeding, best thing to do when you get a new controller, it usually comes with a piece of metal that's actually jammed in the lead where the actual sensor actually locates. I have one of these in my bag somewhere. Basically, I use that to jump out the solenoid, to jump out the sensor. By jumping out the sensor, because basically the alarm set of contacts, feeds off at 1700 ohms. When you have that jammed in there, it basically acts like a short, saying that the compressor's hot as hell. We want to feed the solenoid, and if you keep that in there for 120 seconds, it'll actually finally de-energize the solenoid, but also open up the set of contacts for the control. So this is a good way to actually test that type of control.
Yeah. So the other part of that is if you open it, take it out, it's going to not feed, and then it should trip in that 120 seconds. So I have that same metal clip, and I use it to test it on startups, to make sure everything's working. But I have had issues with those controls, tripping too soon or sensor issues. So what I've gone to doing is if I have a compressor that's been like a nuisance demand cooling issue, I keep a potentiometer in my tool bag. And what I'll actually do is I'll put my ohm meter on there, and I took an old sensor lead, I soldered it onto the potentiometer, and I made it to where my meter leads could touch it and clip on, and I could watch the ohms, and I could turn it up and down, make it feed, make it feed, make it feed, and then get it to where just before it's about to trip, to make sure it's not going to trip prematurely, because I had a couple that we were on a bunch of times. Guys changed sensors, a couple modules here and there. Well, it ended up being one of the modules was tripping like way before it was supposed to, and it wasn't the temp sensor; it was the actual module. So I used that test potentiometer. You could buy a potentiometer pack of like 50 off Amazon for like $6. I mean, it's a great tool to keep in your truck.
You might want to describe what a potentiometer is for some of the people that don't know.
I'll let you take that one.
Potentiometer is a adjustable resistor. They come in all kinds of ranges and all kinds of wattages. Basically, if the range is that we're trying to accomplish what Smarty Pants was doing, basically you want to get something that goes maybe from 0 to I don't know, probably 3K. Because that should cover your whole basis of what you don't need anything crazy. We don't need to go up to 90,000 ohms. The reason why they show you 90,000 ohms in the sheet is basically so you know what it's going to be when you're in a hot ass machine room that's almost 80 degrees. So a 3K potentiometer is basically a variable resistor that basically has you turn the dial. It's going to change the resistance. They use them in trainers all the time. Like I said, you can use them for troubleshooting in instances like this.
Yeah, it also works great for verifying board points. If you think a board point's bad, if it's reading a temp sensor that's messed up, or cable's messed up, do the same thing. That way I set a resistance, I know what the resistance should be, and then I can verify the resistance or reading with it. I mean, it's a great cheap tool to keep in your tool bag, or like in your truck. That way you could trust test things like this that are kind of like nuisance alarms.
Also, before I forget, I was talking about that chart before. Basically, the chart covers temperatures of 59 degrees, which will be 141.4 K ohms, all the way up to 109 degrees Fahrenheit, which goes all the way to 42,500 ohms. Like I said, I'll post that in the Advanced Refrigeration Podcast Facebook group. Be mindful, there are two different types of solenoids. One solenoid is for 2Ds and 3Ds. There is another one that does 4, 6s, and 8s. It's basically, ported differently. One's going to have a bigger port than the other one. Kevin, I know that you're not agreeing with running 225, but I'm looking at some of the appendix tables, and they say that it looks like you will be achieving on a 4D, with 110 degree room temperature and 110 degree condensing. It basically gives you an estimation of what your discharge temp is going to be, and it looks like it's anywhere from 260 to about 280.
Oh my God, this is trash.
Yeah, I know. I'm just saying. I'm not saying it's right. I'm just saying that's what they're showing. You know what I mean?
That's when you need the liquid up to the oil pump. That's when that's like a happy compressor.
just take a full flow 1/4-inch line, just put it right to the suction.
You pretty much probably could at that point. So the other thing I want to talk about is, Brett talked about two different solenoids. So there's also two different demand cooling modules. So the ones that are blue are for the recips. The ones that are green are for the scrolls. I recently had this problem. I did a new startup. Hill Phoenix sent out rack, everything else out there. I'm looking at it. I had compressors having issues nonstop. I'm looking at them. All the low temp discus compressors came out with scroll demand cooling modules.
So what's the difference?
So that the temperature range and everything on it. So the injection when it starts stops, and the sensor, because the scrolls are in the heads, or they're the clip-ons.
Yeah, see, that's what I was confused because, like, I've seen so some racks that I'll see, like Hill Phoenix, you'll see a sensor directly on the discharge line that's clipped on there, and then you get a brand new compressor, and that brand new scroll that you get will come with a sensor that's on top of the head. So when do you use which sensor? Do you know the answer to that question? Because I've never had
I
to
always
call.
use the one in the head. So we had this problem. You ever worked on a proto air, or you
Yeah,
ever had the
well,
pleasure of?
yeah, Proto Air is the one that has the condenser fans up on the top side, right?
Yeah, the
Proto.
ones you take your head off when you're working on it.
Yeah, and protocol. Shit, protocol is the one that is the one that actually has the remote condenser. Yeah.
Yeah. So a
Okay.
proto air, when these first came around, Whole Foods started slapping them all over Chicago on roofs. Well, this is right about the time when everybody started going over to 407A, and had demand cooling modules. First winter, we had nothing but trips, random trips, nonstop nuisance trips
Okay.
on demand cooling in the middle of wintertime when it was like below 10 degrees. So what was happening is we would run low load in these racks, and like 3 to 4 compressors would be off at a time because we floated our head so low that they were actually tripping on demand cooling because of the sensors. When they would come on, the lines were so cold right there, they would trip on demand cooling. So what Emerson actually had us do was drop the sensors in the heads. That way, the crankcase heater still kept the compressor warm enough, the core, that it wasn't going to be an issue, and it warmed up quick enough. So the clip-on discharge lines, we insulated them. We tried everything. The nuisance trips didn't go away till the sensors were in the heads.
Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry. Did they come with crankcase? Well, yeah, it's up north, so yeah, they probably came with crankcase heaters. Yeah.
Yep, the crankcase heaters are already there, but on the discharge lines themselves, the way the condenser and fans were, they would just cool the discharge line down so fast that they would never get a chance to warm up fast enough with it being that cold, and it would just cause nuisance demand cooling trips.
What temperature they trip out at on the reverse?
I don't quite remember. I want to say maybe 60 degrees.
Unbelievable.
I know it's pretty low. What's that?
I said unbelievable.
Yeah, so
So yeah. So on the scrolls, they use those same they're referred to as DTC valves, discharge temperature control valves. The ones that we were talking about first that look like the Y1037s, but they're not. They're basically, they usually have a connector on their flare to connect the liquid. They do have a fitting that fits directly in the head. There is a coil spring that needs to be installed on there, so the actual sensor, gets placed good inside the head. Sometimes you can use some monkey snot on there. Basically the thermal paste to get a little bit more temperature responsiveness out of the valve. If you are changing out the compressor, don't be an asshat and don't grab on that sensor with a pair of channel locks. When you do that, you are squishing basically what is the power head. When you do that, that valve will potentially overfeed all the time and then potentially cause miscellaneous compressor failures. I've seen it happen where, like I said to you before, you should have a solenoid before. Now, solenoids are expensive, so not every manufacturer is basically going to put that in there. So be mindful that, if you are changing out a compressor and using the same DTC valve, which I wouldn't recommend, I would say, if the compressor damaged and you don't know why it actually damaged, replace the damn valve. But anyway, if you don't, just don't squish the temperature responsive power head that goes in the top of the compressor. Do you want to cover the awesome new Bitzer ones?
So the awesome new Bitzer ones are giant piles of crap, but they have this cool readout on them, which actually is kind of nice. So the Bitzer ones, they got rid of their CIC modules and they made some. Well, they took some module that I'm assuming, found on the shelf somewhere. And basically, what it does is it's got a head temperature sensor in there. It's got an alarm set point, and it has a injection solenoid. So it's doing the same thing as the Copeland one. It's the only advantage to it is you can see what the actual temp sensor is reading, which is quite nice, to be honest with you. There's no guessing what it is, so you can actually see what your reading is. But they do not give you a way to mount it. So this thing's designed to be panel mounted, and I put them in a Husband rack from 2005. They would not fit. You couldn't close the electrical panel if you put one in the door because it would hit the back of the panel. No matter what you did, it's too long.
How long are the controllers?
Like 4 to 6 inches. So what was happening is if there was anything in there, relay, I ended up hitting an ice cube relay in one spot. I ended up hitting a cable tray in another spot. So I ended up buying some boxes off Amazon, some like waterproof, like underground lighting splicing boxes. And we mounted them to the front of the compressors. And I took a oscillating tool and cut the square out, and I put them in that way. I mean, it looked kind of hokey, but it looked better than mounting them in the electrical box or anything like that. So this is going to a pulse type solenoid valve, and that's how they're doing their liquid injection. So, but they actually use a orifice. So the fitting that goes in the compressor with them is actually orificed. So that's 5/16 or it's 5/16 to 3/8.
Mm-hmm.
Or no, it's 5/16 to 3/8. And then inside that fitting, it's like the size of a ballpoint pen. So that's how they're doing their liquid injection. They're Go ahead, Brett.
No, I was going to ask how do you know what size port that you're supposed to get? It's a pulse width modulation valve, right? So typically they should be ported, right, for, whatever tonnage that you're trying to accommodate. You said there were big steaming piles of junk, but why? I mean, are they just not cooling the compressor down fast enough, or should they have lowered the temperature?
Well, they should lower the temperature. The fact is, like, you hardly see them inject. And it's the same problem they have with the CIC modules. Like the injection temp was way too high.
Okay.
So I mean, you end up where you could be injecting liquid and cooling that discharge down, but you're not because they have the setting so high. I mean, personally, with the Bitzer, I'd rather see a 190 Y1037 and be injecting its ass off, and me have a cool compressor, and I use a little bit more horsepower to do it. But in the interim, I mean, you're gaining that back on capacity because the hotter that, the more desuperating you have to do, the less condenser capacity you have. So that's what I mean. It's a trade-off there. I almost would like to see what the liquid injection cost versus condenser increase would be. I mean, you got to figure you knock that discharge gas down to 190 from 250. That's quite a large a lot of desuperating that condenser would have to do that it's not having to do now.
did they give you like a temperature range on the actual sensor that you could actually kind of cheat the system and be like, hey, if I put this in series with the sensor, it'll increase or decrease the value, whatever you'd have to do?
I'm pretty sure you could just Google this PLC thing they have, and I'm pretty sure you could just change it. I mean, I haven't got deep into it. I mean, to be honest, it looked like it was already unlocked. And if you just went through all the German nonsense literature, you could probably find it and honestly change it. I haven't got that far yet. I mean, I'm still at the point of trying to get everything running at this place. So, but yeah, that's how Bitzer's doing their liquid injection now. To be honest, like this thing kind of seems like it's a like crossover to their new module, which runs the entire compressor. So they have what is it called? It's not the it's their new variable speed or variable digital compressor. I forget what it's called, but the thing's pretty cool.
Like the Siemens controller that comes with like the Ethernet jack.
So that is pretty much dead, and they have a new digital compressor, and this thing kicks ass. So it's monitoring oil pressure, temperature, doing liquid injection. It's doing all the compressor monitoring.
Is this a large black box?
Yes, and it mounts to the electrical box. And
yes,
on the top,
and you attach it. If you have to have the same software that you use on the Vari-Scrolls, yeah.
Correct. Yeah, I have one coming on this job for the medium temp side for each compressor. It does all the digital unloading, takes a 0 to 10 volt signal. So I mean, this thing kind of seems like it's it's going to carry the CIC replacements until people go more to this module, and it seems like Bitzer's going to start pushing this module. I mean, it's their version of CoreSense, like Copeland has. So now CoreSense for Copeland has taken over all the demand cooling, injection, and all that stuff.
No, that rep that you met when you were over in when you were out in Texas, Greg Cross, he I was working on some Bitzer rotary screws, and the ESC 200s
201.
Yeah, 201, and then they went to, what was the next one? Yeah, it was 200 and then 201, yeah.
Mm-hmm.
So anyway, those are dead, no longer available. So they're changing everything over to, basically the same module that you're speaking of. The only thing is you have to end up programming everything. Unfortunately, we were in the midst of changing out those controllers, and I had the job bid, I had the job ready to go, and then we ended up losing the account. So I didn't end up getting to play with that software and play with that controller, but I know what you're speaking of.
Yeah. So that's their new go-to controller for everything. It seems like, I mean, 201s. I have nightmares from rewiring those things. Everybody would mess up rewiring it because the grounds would change. You know how they would do the sensor grounds? They would have that the binary input. Everybody would mess that up and then couldn't get it to run, and it was the same thing every time.
The ground was messed up.
Yeah. But so let's go over vapor injection real quick. So a lot of especially scrolls, like the big Bullseye store, they're huge on this. So vapor injection is a way of cooling the compressor without. It's basically like a, how do you want to say this? It's a no loss, no gain compressor cooling, because liquid injection, it's a loss. I mean, we have to use horsepower to do liquid injection. I mean, there's no free cooling. So vapor injection, on the other hand, is a win with a loss, because now we're using the subcooler. We're using the vapor off the subcooler to cool the compressors. And at the same time, we're using what we'd be using for liquid injection, that horsepower, to subcool the liquid and essentially make the rack more efficient. So it does two things here. So with vapor injection, it's a win-win situation because the compressors are cooled down and the liquid is subcooled. So we don't have the penalty for having to use horsepower to subcool the liquid, and we don't have a penalty for using horsepower to liquid inject the compressors. So what we're doing is we're taking the subcooler and we're taking the vapor that would come back, that would normally go back to the rack or whatever, and it's going back into the vapor injection line or header, and then that is injecting into the inner stage of the scroll set. So this is what's doing that cooling. So it's in the inner stage of the scroll, it's interjecting cool vapor. Now, it's important to keep this vapor, like 10 degrees max of subcool or superheat, because the warmer that vapor is, the higher the discharge line temps are, because that's your cooling. So say you want a 40-degree liquid step, your subcooler is going to be running 40 degrees. You're trying to hit 50-degree liquid. So you say you're running like a 10-degree TD. Okay, so now you should have a vapor line that's 50 degrees. So if it's 40 degrees saturated suction temp and you run 10 degrees of superheat, you should have 50 degrees coming back to that compressor. Now, that 50 degrees is what's cooling that compressor. Once you start getting it higher and higher, you start creeping up those discharge temps. That subcooler should never be cycling. You need to keep that EPR up. And when that subcooler starts cycling, that's when your compressors start overheating. Especially vapor injected compressors. I mean, running without the subcooler is like a death sentence to those things, because now you have no demand cooling. You may have a temperature clicks on there depending. You have no demand cooling on there. You just have that vapor. You're relying on that vapor injection to cool that compressor. Vapor injection compressors, when they are not operating with that, will overheat.
And you pull off the discharge line temperature sensor, right? That's the correct thing to do?
Yes. And just let the paint melt.
It bubbles. It bubbles.
Yeah. The bullseye stores. How many have you seen with the paint that's burned off the top of the compressors?
Let's just say
probably everyone in Texas.
So let's just say for the first 3 months I was here, my name was Captain Subcool because that's all I was fixing. Case wasn't pulling down temperature, it's a subcooler. Compressors weren't maintaining capacity, it's a subcooler. That's all it was for 3 months. And they're like, that's all you fix. That's all he knows how to do. Fix subcoolers. That's it. That's because that's what was wrong. But yeah, like the paint, I saw what the nice steel finish on the top of the head of the compressor because the paint was just off, gone.
Yeah,
it's crazy because the compressors last a lot longer than 3-4 years when you have them working.
Oh yeah, I mean, who wants to replace those giant scrolls? The other thing is, so you mentioned earlier that liquid injection in there. So like a lot of times you'll see protocols now like 448. So once you get to like 404, you could just run vapor injection fine. You didn't need liquid injection with 404 if you had vapor injection. You were fine. Your ratio wasn't real high, so you could run that. Now, once we get to 448, 407A, we also need liquid injection too, because we're getting to the point where at certain times our discharge line temps are going to get too high, so now we have liquid injection. So they originally had that demand cooling solenoid. I believe that is obsolete now, and they are going away from that for the scrolls. So they have now gone to that DTC valve or the electronic expansion valve off of the CoreSense modules.
Before I forget, very, 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 very important PSA. So the Copeland scrolls, typically if they are economized compressors, meaning they have vapor injection, the model number will typically start K, V as in V, E as an echo. The V represents vapor injection. If you have a compressor and it does not have the V and you have vapor injection, don't just take the 1/2 inch or 5/8 line and meter it down to 3/8 or a 1/4 inch vapor injection line because the hole coming out of the back of the compressor is that small. That's intended for liquid. That is not a vapor compressor. So if you get a compressor, before you haul that compressor up on the roof, make sure it has the V in there for vapor injection. Otherwise, you're going to be back in, 3-5 months and wondering why you lost the compressor again. And then the compressor gets ordered wrong again. And then again. And then again. And then again. So just be mindful of that.
So the other thing is the liquid injection ones where you have that port in the back where the older scrolls where you had that like canister looking thing, which is just a cap tube rolled up in there.
Mm-hmm.
Don't be a douche canoe and put armored cap tubes on there and leave the Schrader depressors in, because all it does is block the hole. And just so everybody knows, there's 2 different types of armored cap tubes. There is a pressure control armored cap tube, and then there's one that's designed for flow. So there's actually a larger, it's called an ultra tube. The inner diameter is bigger. So a standard armored cap tubes you grab off a shelf from United or whatever, the Johnson Controls one, that is a cap tube. That is not designed for oil injection. That is not designed for liquid injection. You will not get the flow through it. You have to get the armored tubes with no Schrader depressors and their full-size, full-flow 1/4 inch hoses. I was at a store where they constantly were losing low-temp compressors, overheats, oil burnouts. I found 14 liquid injection hoses that I don't even know how. It was like a trickle through them. You could see they welded a Schrader in the back of the compressor. You could see where the frost line stopped just past the Schrader Pookie. Like, because it wasn't doing anything. They were always injecting because they couldn't get any flow through them.
That's amazing.
And again, there was like 8 compressors out of 19 that were from 2020. And there wasn't a compressor older than 3 years on both racks.
I have to ask, at what point you're like, I think we have a problem. Keep losing compressors. I wonder if we should probably look into something.
I mean, the oil was like motor oil, so I mean that wasn't helping either. It was probably the nastiest mineral oil I've ever. I've thrown away so many clothes.
It's not even worth going in the freaking washer to throw it out.
No, it was. I mean, after the 3rd or 4th oil bath, it was just going in the garbage. I think the first week on the job, I threw my clothes away every day.
Took a 50-pound bag onto the airplane, back down to 10. Screw it.
Yeah, no. But yeah, so that's why vapor injection, liquid injection, like actually paying attention how this is set up is a huge. This is a severely overlooked and missed thing, especially on PMs and other things that guys don't catch. Demand cooling module or 2 not working on a rack. Doesn't seem like a big deal, but could be a death sentence to a compressor or so. And the other thing I want to go over real quick is head cooling fans and coolers. So Copeland doesn't send out oil coolers anymore. I mean, not a big fan of that, but I mean, yeah, they said you don't need them. So, head cooling fans. I mean, I don't know how many racks you go to and you see a head cooling fan or two out. That head cooling fan makes a huge difference, believe it or not, on discharge temps, because that head cooling fan is cooling off that body. And if it's not cooling that body off, all that heat's going into the discharge line, and decrease your condenser size. So everything's about getting rid of that heated compression. The more heated compression you get rid of, the less discharge temp you're going to have. The bigger the condenser is going to be, the less issues you're going to have in the summer. So, I mean, make sure those head cooling fans are clean. I mean, it's a simple, easy thing to do, especially winter work. It's filler work. Make sure you're cleaning head cooling fans and blowing them off. I keep a leaf blower in my truck to do it.
I thought you used a pressure washer. I heard that story.
Yeah. It worked good till it blew the lead off a compressor.
Until they don't.
So, well, those Walmart guys who do the condenser coil cleaning, those pressure washers are kick ass. So they finished early. We were putting the compressor in, so I cleaned the rack house with it. Well, I just wrapped the controls and I just kept everything kind of running all haphazardly, and that way it would blow the water off the compressors as I was spraying them. And I got it all the way done. Everything looked great. They were all clean. And I hit the last head cooling fan, and it must have rubbed through a little bit, and it sheared the pressure washer, cut the whole cord off.
That's amazing.
And just shorted out the 460.
So since we're talking about, sometimes, with all these gas changes, right? You're not always going to go from straight R22 to, 448 or 449. Sometimes, some stores, they'll take 404 and basically convert it over to a lower, global warming potential refrigerant like 448 or 449, any kind of HFO, right? Be mindful, because you are going from a 404 to a 449, that has a higher compression ratio. They will actually have to install demand cooling modules aftermarket. It sounds stupid to even have to say, but make sure that they're wired in L to M, L to M. If you do not wire them in L to M with the control circuit in series that way, where you actually go L to M and then M to L, you'll have what we had, where the demand cooling will trip. It'll go into alarm. And because now it's basically backfeeding through the alarm set of contacts, because it goes through an alarm relay, it keeps the compressor running. It'll shut off for a little bit. And then as soon as the oil failure stops, because the contactor's still pulled in, it just keeps running. Both protectors are tripped, but basically it's backfeeding through the alarm set of contacts. So make sure, the alarm circuit in series goes from L to M, L to M. That's all. Kevin, you want to cover anything else?
No, I think that pretty much wraps up the demand cooling. Just keep those discharge temps down, and everybody's life's a whole lot easier.
All right, guys. Hey, listen, thanks for listening again. I appreciate it. You guys have a good night.
Yep.